Yeah, this one. Testing. There we are. No matching member function for call to remove output device. Yeah, I just have to undo whatever I did. Well, a lot of it anyway. A lot of it. Like too much. Oh shit. So yes, functions must take const references. This is not related to that. So I guess I should say no. And then this. Whoops, also not related. That I don't care. Let's not restore anything except when it has to do with const stuff. What about this one? Probably we want to restore this. Yeah, let's restore that. That's wrong. Yeah, DIFM just went down the toilet. I blocked everything except when you pay. So the free account with advertisement can also not even listen anymore to I don't know, 99% of the channels as of today. That's pretty sad. Nope, not that button. Wait, I have a better one. Mm-hmm. Yeah, well, something like that. No. Git status. Yeah, I changed a lot in everything. Start a thread safe. No, that's what I just came from. Thread pool. Git diff. That's all. Is that all? I want to keep this though. And this. Yeah, I do not have to set anything here. What about a resolve task? Get diff. Also nothing, dude. I want to keep this. Let's reset everything. So what I changed here is I changed what to what const reference to what reference, and that's just wrong. So I have to reset this, restore it, yes. Yes, and yes, and yes, and that's another yes. And loads of yeses because I see loads of highlights which then disappear. Yes, and there's also a yes, and then this one is also a yes, and again a yes, and yes, and no, yes, 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 yeah, yes. No, okay. There's also, and then we have here also yes. Yes, yes, yes. Hmm. Well, that was everything. Well, okay. But I think I also made those changes here. Why not just grab project sources for what reference? That's another way to find it, I guess. No. I think I changed back what I did. It's impossible that it compiles. So this is really waiting for the inevitable compiler. It doesn't error out. Why the hell was this not error out? Really? What? Possible. So this allows me to do a const cast from R to, well, what reference? I have no idea what that is about. Let's go back to thread safe and then edit AI thread safe.h and then find access. I should just look at the diff here. Diff Oh. So the only change that I made, well, apart from that, is adding a const to the read access type. Hmm. Okay, now I understand why it works. Hmm. Yeah, this is not going to work. It's not going to work. I mean, making it const would call this, but that then is the read access type, so then I have to add const here. And then I can no longer use it for the write access type, because it needs to write, so it must be return a non-const pointer. Which therefore means that I have to duplicate these two functions and return a non-const pointer and reference of the overload that does not use const. But that means that my write access type can no longer be const, and that's not possible because my functions take a const reference so that I can pass temporaries. And I don't know why I'm listening to vocals, because I cannot think. What am I doing here? I had something else. Yeah, no vocal. That's what I had. So why is that not working? Just clicking. Yeah. And then I get here and I click here, we get vocals. What the hell? All SoundCloud, yeah, deep text station. That's not where I wanted to go. I just want to play this. Stop. Play. No. No, doesn't do it. Also not. Oh no, here. How can I play this whole list? Oh, here. I've figured it out. Okay, so you click here. I'll give people a link if you want to listen to the same music. Yes, so you cannot do this. I cannot have this type, const or not, because it returns something that I can write to. So I have to redo now what I did before, namely create a new class. Which I call const. Which returns, well, const pointer and a const reference. So now this is my read access type. Yeah, that's too loud. Too loud. This is my read access type. Where's that line? There. It's in class primitive. Okay, so now the read access type, well, dereferences to a const pointer and a const reference. And the write access type dereferences to a non-const pointer and non-const reference. And both are derived from access const. So both can be passed to functions that take a const read access type. However, I also want to be able to pass a write access type to a function that takes a read access type. So access must convert automatically to a const access. Now before I try that by making access derive from const access, that would be the normal way. And then that seemed to fail. Why did that fail again? Well, the reason is that the other way around, I want to go from read access type to write access type. I want to make that possible, but only if you do a const cast. I want it to look like that. And that's not going to work, I guess. It's just not going to work. Unless I can overload const cast. Not sure how const cast works. Maybe you can specialize it, I mean. At any rate, if I derive access from const access, and then this is simply the base class of that class, so you can also always do a static cast from here to there. And because no reason I don't want to allow that, which is ridiculous. Maybe because a cast is a cast, and by that time you should be smart enough to know what you're doing. But I just want a const cast, so I cannot make this the base class of that one because then a static cast would work. So what I have now is better, but then what happens if I want to pass this to that? Well, that means that I need an implicit conversion from access to const access. Here's access, okay, trying to pass it to something else, operator, const access, const reference, const. So now I have a const access, I mean, this access is my write access type, because I always pass that as a const. So all my member functions must be const, therefore also this one is const. And this is operator type, parenthesis, which means that it automatically converts to const access, const reference when needed. Well, then we still have to do it, because now we have an access type. What I could do is convert it, say, to the base class here. And it's const anyway, so I can do const pointer base equals this. And then we return a static cast. Now let's make it a reference. Two things in one step. And then I do a static cast from base to what we need here. No, that's a template, right? But it's also a wrapper. Which is more or less the same as a reinterpret cast. Again, nor virtual functions. It's probably a nice name for that. If they don't have that, but yeah, the size of access equals the size of access const, and the same holds for const access. Is also the size of const access equals the size of access const. So if I just cast access to the base class and then back to const access, then absolutely nothing changes in terms of memory footprint. The only thing that changes is the interface. So that's always allowed, I would say. Apart, of course, when you would have a virtual table, which is then incorrect. But I don't have a virtual table, so hell, this is just a wrapper around a pointer. This is the only member that we have. Size of both is equal to a pointer. You could add a static assert here, you know, like static assert size of both equals to the size of a pointer. But yeah, I mean, I don't know. I believe it's the comment is already there. So now we can go from access, which is the write access type, to the read access type, const access. But we can still not go back. So now I want to go from the read access type to the write access type using a const cast. Well, let me find an example where it goes wrong. Please don't compile, because I would basically not know what to do. Now it compiles. Or is that nonsense? Okay, I'm getting nervous. Did not compile. Are we not lucky? Error. Const cast like that. Yeah, okay. That's the only place. I guess. In a million lines of code, the only place where I try to do this. Could be kidding me. Well, the const cast, yes, but converting a rad into a what? I would have expected it to happen, to have been done sooner or before, I mean. Okay, so specializing the const cast would work. So this is a red, and I want to const cast it to a what? Well, at Let's add a const here, because that's not really a const cast anymore, right? I mean, it's more like a reinterpret cast. But I want to use a const cast, damn it. Going from a red const reference to a what const reference is a const cast. Therefore, I want this to compile. Maybe it's not even possible. Then I want something that's not possible. Let's ask Google. Bloop. Can you specialize const cast? What the? You must use specialize. Of course, you must use specialize. It's just not answered. It is not answered. I'll give one more page a chance. Nope. Starting to be afraid. Shall we ask ChatGPT? No. Const type. Can I specialize const cast? I want to make const cast full const reference bar work, where bar is a bar const reference. Hmm. I could do this, or this is nonsense what it says, but it is an idea. If I put explicit in front of it, so it's still an idea. It's still an idea. Yeah. So what you could do is not const cast it, but make a temporary. So make it temporary that must be explicit. No, this is not good. No. The problem with this is that then I have two of those objects. And both are going to have the destructor calls. Or I could do something really nasty, yeah, but then it's not a what anymore. I could cast it to something else. I could construct something else. Like, I could define here a const cast object. Or is it a keyword? No, it's not a keyword. No. That's dirty. But yeah, I think we're getting somewhere. No, that's really dirty. Really, really dirty. This is syntax that I want. So I want a random syntax, I don't care what. Well, I did care, but that was not possible. I have a read access type. So the type is RAT, read. And my function takes a what, a WAT, a write access type. The moment I do that, this read access type tells me by the type and also by the name, that's my convention, that it only gives me a read access, right? So I'll never write to it. And I'll pass it to a function that does write to it. So it should not compile, right? But no, I want it to be possible to change my mind halfway. I just want to pass my read access type to a function that takes a write access type. But it must not, compile out of the box. I want to be very aware of it that I'm doing this. So I thought if I force myself to use const cast, which is super dirty, I really hate const cast, then I know that I'm, having something that is basically a const pointer or a const reference, and I'm passing it to a function to something that is then basically a non-const or a pointer or non-const reference, aka const cast. But the types have to be different. I mean, I tried a different way, but it's not possible. I mean, the function just really has to take a write access type. And that must be a reference, and therefore it must be a const reference. The function must take a what const reference. There's no way around it. Now, this is already const, so you can do whatever you want, but no const cast is going to help there. So I really need a reinterpret cast, or a static cast would work. Maybe that's better then. I just dropped the whole idea of using const cast, and I'm going to be satisfied with static cast. So you have to explicitly static cast it, and then, well, then it will compile. But yeah, you know, static cast is supposed to be totally safe. I don't know if it would trigger alarm bells in my mind when I have to use that or look at it later or something like that. So this way, at least I have the string const cast like right here, if you do it like this. I don't want to do this. Let me try AI thread save. And then I define a const cast function. So, like that. Where the const cast then by default casts from read to write. And we're purely looking at, yeah, at the grammar, like at the characters here. Like, does this look nice? I think it looks nice. It's a const cast, but specific for AI thread save. And it casts my underscore R thing. And since it can only do one thing, it can only go from read access type to write access type. So the write access type is not mentioned here, but well, I think this if I can get this to compile, then it's probably not that bad. Right, so let me try that. So now I need to write a function called constcast in AI thread save. And that does this conversion. Now I bet we are in the correct namespace here. Yep. AI thread save. So undo, redo. And this must be a template. Everything is a template. And it's going to return the write access type as a reference. So it's going to return access wrapper as a const reference. And it's going to take, because it has to know what wrapper is, of course, but it knows that because I'm passing it, the read access type, which is a const access. I think that const reference will work here. Yeah, so no R value required or anything, right? No. Yeah, this is correct, I think. So let's call it access again. And then the question is, what goes on my ... here? Explicitly. I will write that correctly. Convert a const access to an access type. think it's much like this one. We just make a base class first. I mean, const access has the access const as the base class. And then we just static cast it back to the type that we want, which is an access. So it's exactly the same trick, but the other way around. Now, what do you think? Did I miss a semicolon? Still an error. What the hell's going on? Didn't even read the error. Yeah, expected unqualified ID. Is const cast is const cast type? Sorry, a keyword? No, it's not. I really don't know. No. No. No way, dude. I don't believe that. Really? Really, really, really? Well, maybe it is. It's a keyword. You gotta be kidding me. Static cost as well. Reinterned cost. All those I thought they were just template tricks. Well, that's annoying. Oh, then I have to think of another name of this for this function. But I really wanted const cast. Dang. Okay, we want to use some cost. Um, okay, chat, what is a good word here? Converting a read access type to a write access type. What kind of cost is that? It's like, yeah, but you told me you were only going to read it, and now you betray me. Betray cost. Change your mind cost. What about what cost? Write access type cost. Yeah. Okay, go with that. What I want to do exactly, I've been talking about that for the last hour. I want to have a read access type and then pass it to a write access type, a function that takes a write access type. But only in a way that forces me to make that very explicit. So it must be allowed, but it must be very explicit. Hey, Michael. Yeah, that's a good idea then, maybe. Instead of just still putting the const in there. Const access cost. Yeah, I like the idea. The what was a bit. I mean, I'm casting it to a what though. You know, it's I have a red and I cast it to a what. It's not that bad. Maybe just what const cost. What const cost. I think I'm. Yeah, sorry. I think I'm going to stick with the what cost. Somehow I like it. It costs to a what. It doesn't look as dirty as the const, but kind of says exactly what it is doing. Going from red to what. And it compiled, didn't it? Yes, it did compile. So there was a complete sidetrack. The only reason I did this was because I saw that I was writing to a read access type, and I was like, what? How can that even compile? I always thought that if I declared something as a read access type that I wouldn't even be able to write with. So it's just making things a little bit more maintainable, I guess. So there is no real difference between the two types. Both lock and mutex. So yeah, but still, you know. The tea is ready. I don't know if you write that like that. Indistinguishable. Looks weird. Indistinguishable. I think I got it right. Blah blah blah, something like that. Yeah. Well, and then what the hell did I change here? Oh, everything. So clean. Right, so back to what I was really doing. Yeah, that was totally sidetracked. So we write this to a file, the moment that it doesn't crash. And then we have in that file create a pipeline layout. Seriously, only here? Okay, so I have a set index here. Set index 0 has a binding 0 and uniform buffer. And a different set index has also binding 0. Also a uniform buffer. Same stage. But yeah, that doesn't say much because this is my own function. It's confusing, that's what it is. What is being passed here? Three things, I guess. Three times descriptor set layout. But hey, then still. I think that's the first descriptor set, the second descriptor set, and the last descriptor set. And the layout of the first and last are the same. And it's still being passed. Although they are the same, right? I mean, the pipeline layout gets past descriptor set layouts. And then I have one descriptor set layout per descriptor set. Is that so? That's what it looks like here. Oops, not here. Let's have a look at this function. It doesn't look like. Actually it does. This is IMQ. I have to look at. I guess here. Yeah, it's a vector with realized scripted set layouts. But the question is that thing having so some significance in the size and the order of this vector? Yep, it's per set index. Put the handle in it per set index. Per set index hint though. It's not necessarily equal to the actual set index. The create pipeline layout is doing this one, pausing that. It's just handles, scripted set layout handles. You see, I'm not convinced. I don't think the size or order of this array here has any significance. So passing the same handle twice doesn't seem to make any sense, even though it's being done here. And it is accepted. Let's have another look at this. Why is this bright? Off, I click on off and now I click on on. And nobody understands it. Okay, there it goes. Sure. And then it becomes this. Nobody gets this. It's broken. Now what the fuck? Why do things suddenly break out of nowhere? Yeah, reloading the page seems to work. pset layout is a pointer to an array of VK descriptor set layout objects. Set layout count is the number of descriptor sets included in a pipeline layout. Oh. So it says layout count, but actually it's a descriptor set count. Because if every descriptor set is the same layout, then I only have one layout. Set layout count, okay. Number of must be less than or equal. Set layout count is not 0. P set layouts must be a valid pointer to an array of P of set layout count valid. Or we can null handles. Yeah, now you have here set must be less than the VK pipeline layout create info set layout count provided when the layout was created. That seems that, assuming set here is the set index, that the index of this array must be corresponding to the actual set index. Tuh. I could ask ChatGTP, but that's not conclusive enough. I think I'll ask on Discord. Let's see, do the, does the order of okay, pipeline layout, now let's call this, of the dot, no, let's not use a dot because, do I use a dot? It's also C, right? We just call it dot. P layouts array of that. Does the order of the p set layouts array of VK pipeline layout create info have a specific meaning? It seems that they must correspond with the descriptor sets, and then IE this set is 0 as the layout at p set layouts 0. Let's replace 0 with I. So I wrote this, does the order, blah, blah, blah. Oh well, so hopefully someone will answer. Someone is typing. Someone stopped typing without hitting enter. Oh, there it is. Yes, set equals I has the layout in p set layouts I. Okay, whoa, wow. Shocking. That is shocking. I don't think my code is doing that. I'm just setting it to this vector here. It said that it is sorted, but how is it sorted then? This here strongly indicates that it is sorted by the set index hint. Very confusing. Let's see where the thing comes from. What does sorted mean anyway? I mean, if it is sorted by the set index hint, then there's nothing to sort. It's just setting this hint gives the element, period. What to type? Thank you. Thank you. Damn it! I want to drink hot chocolate milk. Where's my hot chocolate milk? You know, I can think about this problem while making hot chocolate milk. So Zar, I told you a long time ago I was going to participate in a competition. I was not even a finalist. I did badly in algorithms. However, now I can study C++ calmly. Zen. I'm not sure I get it completely, Zar. I guess my memory is not that good that I still remember that you told me that you were going to participate in a competition. But I guess, okay, so I assume you told me that. You did very badly in algorithms. And then you make a jump in the reasoning. However, now I can study C++ calmly. So because you lost, you can be calm now, or I'm going to make some hot chocolate. The dishes are here. They have to be moved as well. And then this must be moved away. Right. This as well. Yeah. Yeah. Let's have a look at the core of this function. That's curious. Is it only called here? Or we didn't find something? Because we look for pipeline layout. Okay, we look for a pipeline layout and we cannot find the pipeline layout in the cache. Then we create it. Okay. Create an identity map. So the in this case the set index int is equal to the set index. And that's when we create the thing. If this is the only place where I call create pipeline layout, then in fact it works because set index int equals the set index. Now that's IMU. I don't care about that. It even has a single element, so the order is not important at all. This is then the definition and debug output. This is the call that we just looked at. Here I have a declaration, and here we have something else that doesn't pass an empty vector even. So it is the only place. It's really the only place where it is being called. Well, I guess that's worth a comment. So we're calling this function from realize pipeline layout. Okay, so the index of p set layout this is the set index. That's more or less a little bit the other way around, right? Say the layout of descriptor set I Man, again, must be able to phrase that better. But how? Maybe some hot chocolate milk will help me. Scientific experiments. Let's see if the hot chocolate milk actually makes this easier. It's too bloody hot to drink. Everywhere else I call this a set index. Why would I now suddenly do this difficult? Index hint map. Something like that. So the set index here is the actual index of the set, in the shader code. So that is, the I here is set index. Set index hint is some random choice that I make. That then later is possibly mapped to the actual set index. But it only happens when I find a layout in the cache that I can use if I possibly apply some kind of mapping between them. But if I find it in the cache, I don't have to create it. So at the moment that we do create it, which is here, the map is always the identity map, and that's why it works. Now, yeah. While writing this, I didn't realize that. So I have a descriptor set layout here per descriptor set. Set 0, set 1, and so on. And I thought I only had bindings. That is not the case at all. So I'm pretty sure that I sort these things in a certain way, and we're sorting then means that the order does not matter. So to define a canonical sorting based on I think I was sorting it by I have no idea. But then the order doesn't matter, right? And it does. The order is exactly the set index. Now, how many descriptor sets do I have anyway? I think that's already clearly visible here. For some reason we do not use set index 0 in this random generation. 1, 2, 2, 1, 1, 2, 1. What the? Is there never a 0 here or what? Oh, here's a 0. The largest one is 2. Maybe sometimes I generate something that doesn't use 2. So like in this case, we have a stage that doesn't have any declarations, and a stage that only uses set index 0, and then a third stage that also only uses set index 0. In which case we have only a single descriptor set. So this by coincidence then is, well, I don't think the content is correct. But yeah, there's one element, okay. And then in this case we have absolutely nothing. Oh wait, yeah, here. One declaration, also one descriptor set. And again, one entry. Is that by coincidence or what? This has 2 as the largest value. So you would expect 3 descriptor sets, and therefore also 3 descriptor set layouts. Again, pure coincidence, I think. Let me find at least one case where it doesn't work. Okay, here we have one that doesn't work. We have 3 descriptor sets. All 3 are actually being used here. 0, 1, and 2. And my array only has 2 of them. So what is the layout of number 2? Crash, overflow. Yep, not working. I did something very wrong there. Omdat ask how fast would you be able to remake Flappy Bird? I don't even know what that is. Right, so this is, I think that. My descriptor set layout object has a vector with descriptor set layout binding. It clearly is using a dynamic size here for the vector. Reset sets the size to 0. Hey Bear. Bear is back. I'm leaving in 8 minutes though. So tomorrow I decided to go to this party on Sunday. So tomorrow I go to a friend to stay the night there, because otherwise to travel is too far in one day. So I'm staying the night there, and then on Sunday we go to the last part to where that party is. So I won't be online the whole weekend. Maybe I'll send pictures to Discord. just as long as the picture not for me, of me, I mean, we can do that sneakily. I want to have to do something in the train. Normally I take a tablet with me, but I don't think I will do that this time. I'm not sure. I don't know. Probably shouldn't. Well, then I take my phone with me. Or at least I can play chess on my phone, so it's okay. Yeah, I think I'll stop already. I want to stop really in 6 minutes, and then I feel already so pressured that I cannot do anything sensible. Yeah, got to fix this. We gotta fix this. You gotta fix this. You gotta fix this. Not now. I'm gonna play chess. Let me try to play like I play on my tablet. Crushing everyone. Doesn't feel like crashing. Crushing. Oh. The guy wants to go after my pawn. Well, that's pretty annoying. I want to put my king here and then I get check. If I put this, I have a weak square here from here to Tokyo. And if I don't do anything, maybe I can move back. And then move the rook. How to untangle a lost position. One, two, three. I lose my pawn. Oh, really? Oh, so bad. So incredibly bad. Yep, absolutely horrible. Absolutely horrible. I think I'm -8 or something. At least that gives me a chance to defend this pawn again. If I'm not giving away my queen, that is. I can go here and then I lose my queen. And I go here and then I lose my queen as well. No, not yet. Not yet. Yeah, it's absolutely horrible. That's what it is. Horrible. Threatening to win this pawn is not even that bad, but this pawn, I don't want to lose it. Don't want to lose it. I should resign, really. This is so bad. This is so bad. Man, it feels like playing against a computer. Now it's going to take this, and I cannot even exchange the knight. So then he's going to take their check. And then I have to go here, otherwise I get a fork on my queen. And then, now the queen comes here, I could take the knight. So the knight's probably going to go back then here, a check. I'm in the corner. I think I'm just going to do this anyway. I have to go all the way here, I think. Takes with a surprise. Can take with the queen. Go down maybe. Yep, with the queen. Let's not go into pinning. 2 choices. No, 1 choice. I don't want to get pinned there. Well, then I get that check, and then I don't have any choice anymore. I have to go there anyway. But hey, at least I'm attacking something. Check again. No, I have to go here. And then I lose my queen. Okay, time to resign. Man, that guy played like a computer, totally. Let me see how many errors this guy made. I mean, I play bad, that's for sure, but... I thought I had... Okay. So the computer move is F4, 1.6, and he does the bishop. 1.3. 1.1. So that was not the best move. Oh, that was a bad move. That was a bad move. I should have done this one. Why? Why not, I guess. It's a draw. That is lost. The castles. Now I'm better. Wow. I should have just taken the queen. I didn't. Again +2. Now he goes back. Plus 2.5. Well, it's hardly worse than the other way around, but I had a plan, but it didn't work. 2.3. Oh, 5. Really, that rook move. Oh, not so really bad. Yeah, 6, 7, and now 3. Nice. He's definitely not cheating. That's pretty clear. 5.4. 9. I think I picked the worst move possible, going from 5 to 9. Normal people go from 9 to 5. Take 8.7, 9.5, 8, 9.5, 10.11. Yeah, just check. No, not this check. What? Should have put a rook behind it. 12.5. And then he's on. Yeah, okay. Yeah. And we lost another game. As usual these days. Okay, I'll see you on Monday, or yeah, probably.